Okay, let's go ahead and start talking about the issuance of bonds payable. In this slideshow, I guess I'd like to do three things. First, we need to be able to compute the issue price of the bonds. If we issue some bonds, we may receive face value, we may receive more than face value, we may receive less than face value. What we will receive is the present value of the cash flows promised under those bonds. Then we'll do a simple example of issuing bonds at par value, and then we'll issue some bonds at a discount. We'll move on to issuing bonds at a premium, I guess, in the next slideshow. First, computing the bond issuance price. If we're going to issue bonds, again, the first thing we have to do is figure out how much they're going to sell for. Now, obviously, in a real example, this would be an actual data point. We'd issue the bonds, and whatever the bond buyers gave us for them would be the issue price. For our purposes, though, we're going to try to compute the issue price up front. Now, as we saw in the previous examples from the finance.yahoo.com, if the coupon rate exceeds the market rate, or that is the yield to maturity, the bonds will sell at a premium. If the coupon is less than the market rate, the bonds will sell at a discount. When we issue bonds, what we're selling is a stream of future cash flows. We need to be able to determine the fair value, that is, the present value of these cash flows. Let's go ahead and take a look at an example. Let's assume we're going to issue $100,000 face value of 10% 5-year bonds. The bonds pay interest each December 31st. The bonds are dated January 1st, 01. They're issued January 1st, 01. And they mature 5 years later, December 31st, 05. The annual cash interest payment is $100,000 times 10%, or $10,000, and we're going to assume the bonds are sold to yield 12%. Now, we know without doing the calculations that these bonds don't pay enough interest. The market wants 12%, we're only paying 10%, so the bonds will sell at a discount. Let's try to draw a timeline picture of the cash flows. First, there's our series of 5 equal annual interest payments. That times t equals 1 through t equals 5. We have our $100,000 face value, or principal, that will be repaid at time t equals 5. And our question is, what's the value at time t equals 0 of those promised future cash flows? Again, we can view the 5 interest payments as an annuity and the principal repayment as a single sum. The present value of the interest, we take the present value is the present value equals the amount of the payment times the interest factor. The annual interest payment is $10,000. The interest factor for a 5-period 12% ordinary annuity is 3.604776, giving us a present value of $36,047.76. The present value of the principal, again, now this is a single sum being discounted for 5 years at 12%. Present value $56,742.70 for a total present value of $92,790.46. So in line with our expectations, we find the bonds sell at a discount. They sell for less than their face value. If you need a refresher course on computing present values, there's a document on Angel that I typed up some years ago, and I keep posting it on Angel in case anybody needs it. Now, just one thing to reiterate. When you go to find the present value of a bond, you always discount it at the market or effective or yield rate of interest. Basically, what we're trying to do in computing a present value is we're trying to find what's the value today of this promised future payment. So what's relevant in terms of assessing the value of a future cash flow is going to be the current credit market conditions. What's the rate of interest appropriate for this promised future cash flow? The interest rate is a function of the real rate of interest. It's plus the inflation premium, plus the risk premium associated with default risk for that particular buyer. So we always discount it at the market rate of interest, not the coupon or stated rate. Now let's go ahead and go through some examples of how to account for bond issuances. And we'll start with the simplest example, where the bond is going to be issued at face value, and it's going to be issued on its dated date. So let's go ahead and we'll make all these nice short 2-year bonds so we can go from beginning through the end of the cycle. If we made it a 10-year or a 20 or a 30-year bond, we would have to do 10 or 20 or 30 years worth of entries to get to the completion, which seems sort of redundant and like a waste of our time. Anyway, let's go and assume that ABC Corp wants to issue $100,000 face value of 10% coupon 2-year bonds. The bonds are dated and sold on January 1st, 01, pay interest each December 31st, and mature 12/31/02. The bonds are sold to yield 10%. Now again, we know intuitively the bonds pay 10%, the market demands 10%, these bonds should sell for exactly their face value. Let's go ahead and confirm that though with the computations. The present value of the interest, 10,000 times the present value interest factor for an ordinary annuity, 1.735537, is 17,355. The present value of the principal is 82,644.63 for a total of $100,000, again jiving with our intuitive expectations. On January 1st, 01, we issue the bonds. We take in $100,000 cash and record the liability bonds payable. Of course, we don't record, we're going to be paying interest over the next 2 years, but that's not recorded yet because interest is accrued over time. We don't owe anybody money for interest at this point. At the end of the first year, we make our first annual interest payment, $10,000 cash. At the end of 2002, we do the exact same thing, another $10,000 cash interest payment, and then we pay the bonds off. Again, they've matured. We have to pay off that IOU. Next, let's take a look at an example of bonds sold at a discount. I apologize for the random things that are popping up there. I try to set up these things to do the animations where things pop up in sequence, but it gets a little bit involved, and I'm not terribly proficient at PowerPoint presentations. Anyway, let's take the exact same bond issue, but now let's assume that it's sold to yield 12%. In this case, the market wants 12%. We're only paying 10%. Nobody's going to be willing to buy the bonds at face value. To sell them, we're going to have to drop the issue price until their yield, or effective rate, equals the market rate of 12%. Present value of the interest, again, a 2-period, 12% ordinary annuity, excuse me, $16,900.51. The present value of the principal, $79,719.39. Total present value, $96,619.90. We go ahead and record the issuance. We're taking in cash of $96,619.90. The bonds payable liability is recorded at its face value of $100,000. We always record bonds payable at its face value. That is the amount of our legal liability. Although we only received $96,619, we've got a written contract saying we will give you $100,000. The difference between the face value and what we received is the discount on bonds payable. And there's this T account slowly taking shape on the right-hand side. There we go. The discount on bonds is a valuation account that is presented alongside the bonds payable on the balance sheet. So on our balance sheet, we'll have bonds payable less discount on bonds equaling the carrying value of $96,619.90. Now, we need to amortize this discount to interest expense. The discount represents additional borrowing cost to us. In addition to the $10,000 of annual interest we're going to be paying, we borrowed $96,619, and yet we have to repay $100,000. The $3,380 difference represents additional borrowing costs to us. Okay, so again, the discount on bonds represents additional borrowing costs for us. We need to amortize that discount to interest expense, and we have two methods available to us. First, and easy and not terribly useful, is straight line amortization. And again, for straight line amortization, just like straight line depreciation, we'll take the amount of the discount and divide it evenly over the life of the bonds. The preferred method is the effective interest amortization method, which we'll talk about a little bit more in just a few minutes. Now, assuming straight line amortization, we would take that $3,380.10 discount, divide it over 2 years, and get an amortization rate of $1,690.05 per year. And again, there's that T account taking shape on the right. There we go. At the end of the first year, we would record our cash interest, $10,000, and then in addition, we would also amortize essentially half of that discount, crediting the discount on bonds payable and debiting or adding to interest expense. So after that first year's amortization, the balance in our discount on bonds is $1690.05. we would do the exact same thing at 12/31/02, another $10,000 cash interest payment, another $1690.05 of amortization, and by doing so, the discount has been completely amortized, and all we're left with on our balance sheet is a $100,000 bonds payable liability. And okay, now in the previous example, we amortized the discount using straight-line amortization. Now, like straight-line depreciation, the big attraction is simplicity. Basically, you do one division calculation and you use the same number year in and year out. There is one problem. It's not really. There is a problem though. We had the same interest expense each year, $10,000 cash plus the amortization, for a total of $11,690.05. We have a constant interest expense of $11,690.05, but the net carrying value of the debt is changing. Okay, at the beginning of the year, year one, the bond carrying value was $96,619.90. We had interest expense of $11,690.05. So the apparent interest rate in the first year, the interest expense divided by the carrying value, was 12.099%, or essentially 12.1%. In year two, the carrying value had risen because we amortized some of the discount. The interest expense was still the same, and so the apparent interest rate, interest expense divided by the carrying value, had fallen to essentially 11.9%. And so, since this is the same borrowing transaction, shouldn't we have the same interest cost as a percentage of our debt each period? Now again, in this example, it's not a terribly material difference, but if we had a case where we had a really substantial discount or really substantial premium, for example with a zero coupon bond, then the difference really could be material. To solve this problem, we'll instead use what's referred to as the effective interest method, and it's really a simple three-step process. Step 1, interest expense is computed as the carrying value of the debt, again the face value minus the discount, or the face value plus the premium, multiplied by the effective or market interest rate, and that gives us our interest expense. Now of that interest expense, some portion is the cash or coupon interest. Whatever is left over is amortization. So essentially interest expense minus cash interest equals amortization. So in this case for year one, interest expense would be $96,619.9 times 12% equals $11,594.39 minus our cash or coupon interest of $10,000 leaves us with our amortization of $1,594.39. So in this case we would record interest expense $11,594.39. We have our credit to cash for $10,000, and again the difference, essentially a plug figure, is the amortization of that discount on bonds payable. And then we've got our T account over to the right again, illustrating what we just did. For the second year, the face value is still the same, but the discount has been partially amortized, so the balance there is down to $1,785.71. Again, see the T account. For the next year, we do the same three-step process. First, interest expense equals the carrying value times the effective rate, or $11,785.71, minus the cash interest of $10,000 equals the amortization, $1,785.71. And notice that this exactly amortizes the remaining discount, so the discount on bonds account is down to 0 after this. Now that we've seen how the effective interest amortization method works, let's go ahead and put this into a nice tabular format where it'll be real easy to use. I'm not even going to try to make this thing appear bit by bit. Basically, let's read across the line at the top with the column headings. Again, we have the period, year 1 versus year 2. And again, think of the three-step process we go through. We start with a carrying value, multiply that by the effective rate, and that equals the interest expense. Subtract out the cash interest, and what you're left with is the amortization. So for the first year, we'd have the computations as given. Second year, we have the same computations as given. By the time we're done, the carrying value is up to $100,000. You can recreate this table at will. There's no need to memorize the format of any sort of table. In the textbook, they give you 2 or 3 or 4 different formats for these amortization tables, and students often get fixated on trying to memorize a certain format. And again, there's really no need to. If you can remember that nice, relatively simple 3-step process, you can talk to yourself and recreate the table at will. Now, looking at the amortization table for a moment, we see that the carrying value from period 1 to period 2 went from $96,619.90 up to $98,214.29. It changed by the amount of year 1's amortization, $1,594.29. So basically, if you look at the first row of numbers, we take the carrying value of $96,619.9, add or subtract the amortization of $1,594.29, and that gives us our carrying value for the next period. For year 2, we start with a carrying value of $98,214.29. We add or subtract, as the case may be, the amortization for the period, $1,075.71, and that gives us our beginning of year 3, end of year 2 carrying value of $100,000. The question then becomes, how do I know whether to add or subtract the amortization? And there's two ways to keep this straight. First, one of the purposes of the amortization is to get rid of the discount or the premium. Basically, by the time we're done, by the time we get to the bottom of the table, the carrying value should equal the face value of the bonds. So in this case, we should be moving towards $100,000. We start at $96,619.9. We should be moving up towards $100,000. If we had subtracted that amortization of $1,594.29, we'd be moving in the wrong direction. The carrying value would drop to $95,000, and some odd dollars. A second way we can think of this is look at the algebraic signs, the plus and minus on the amortization number. Interest expense was $11,594.29. Minus $10,000 leaves you with a positive $1,594.29, which means we'll add that $1,594.29 to the previous carrying value. As we'll see in the next slideshow, if these bonds are issued at a premium, the amortization would have a negative sign in front of it, indicating that we should be subtracting the amortization from our carrying value.